All right, jumping right into lesson 21. We're going to talk a little bit about exponents, okay? Especially within variables, when a variable has an exponent. Okay, so let's start right here by looking at if you have something raised to the first power. So x raised to the first power is just itself, okay? So let's say that it was 5 to the first power. That would be 5, okay? So x squared means x times itself. So if we just put 5 in for x, that would be 5 times 5, which equals 25, okay? X cubed over here, if it was 5 cubed, that equals 5 times 5 times 5, which is 125. Okay, so that's how you work through that. And that's how you make sense of it, okay? So x to the first, it's just itself. X squared is x times x. X cubed is x times x times x, okay? And you can put numbers in for your x and you can solve problems. Now, we're going to be talking about, well, what do we have if we have something like this, where we have x squared times x cubed, okay? So we might have something like that, and they want us to make it more simple. Okay, so let's go back up here and look at this x squared. So our x squared was x times x, and our x cubed was x times x times x. So basically, you can say that if you multiply these two things together, that's the same thing as this, our x squared times our x cubed. So that's actually 1, 2, 3, 4, 5 x's. So that would be x to the fifth. Okay, so x squared times x cubed is x to the fifth. All you have to do is add those exponents. You add your 2 plus your 3, and you're going to get your answer. Okay, so let's work through another example. This is practice letter A on page 93, towards the bottom of the page. So remember, when we have these like this, it's like saying times, 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 okay? So we have all of these variables, and they're being times by each other. Okay, so to answer this question, if you want to make it a little bit easier, you write all of your x's together first, right? Because it doesn't matter which order we put them in, you're still going to get the same answer. So we have x, x to the fourth, x cubed, okay? So now we're going to bring down our y's, and we're going to add our y's in here. So we've got a y here and a y to the fifth over there, okay? So this is raised to the first power, because remember, x to the first is actually x, okay? This is raised to the first power, okay? So you can't pretend that that's a 0 there. It's not a 0, it's a 1. So we're going to add our exponents together, and we're going to add 1 plus 4 plus 3 and get x to the 8th. And then we're going to add y to the first to y to the 5th, and 1 plus 5 is 6. So this becomes your answer. When they ask you to simplify that, that's what you're doing, is you're combining all of the x's together and all of the y's together. Okay, so and this is example B, page 93 again. So we're going to put our common variables together. So we'll do all of our x's. We've got an x cubed, we've got an x, and we've got an x to the 7th. We've got a y squared and a y to the 5th. And then we've got an m and an n. Really lonely over here. There's no other m's, there's no other n's. Okay, so we're going to combine our x's. Remember, this is a 1. So this is x to the 11th. This is y to the 7th. And then we have an m and an n there. Okay? Sometimes when we're going to do some problems here in the future, it's good to find a system of writing your variables in order. And you write them in order with the highest exponent going first. So for example here, I have x to the 11th first, and I like it there because there's more x's than there are any of the other variables. Here there's y to the 7th, that's the next biggest one, and m and n are interchangeable. You can do either one because they both have 1 m or 1n. Okay, so this will make more sense as we add like terms and do different things like that. So sometimes it's good to be consistent in the way you write your exponents because it makes your problems make a whole lot more sense as you're trying to solve them. This is example C from page 93 in your book, and we are going to kind of review adding like terms, but we're going to be using exponents here that have different powers, or our variables having exponents. So our variables here have exponents that are different things. So for example, this has an xy and this has an xy, but this is an x1, y1, this is an x2, y3, okay? They are different. They are not the same term. Even though they both have xy, they can't be called the same thing because this one actually has 2 y's, this one has, or I'm sorry, 2 x's, and this one has 3 y's. This one only has 1 of each. Okay, so our like terms in this problem, this x squared y cubed, okay, there's one here, oh, and there's one right here. Okay, so those are alike. And then we have an xy and a yx. Remember, it doesn't matter which order those things are in, they're the same. Okay, so we are going to say, let's add these two guys together. Well, a 2 plus a negative 8. Signs are different. This is a positive, that's a negative. You're going to subtract. 8 minus 2 is 6. The 8 is the bigger number, so it's going to stay negative there. And I'm just going to write my biggest exponent first and then my smallest. That way I can just start to be consistent now. Okay. Then we have 1xy and we have a negative 5yx. So we are going to add these together. 1 minus 5 basically. One's positive, one's negative. We're going to subtract. 5 minus 1 is 4. And the 5 is the bigger number and it has a negative in front of it. So we're going to keep that. And it doesn't matter which way we write this. So I'm just going to do it xy. Okay. This is your answer. That's what they want you to do when they ask you to do like terms, when you add them or subtract them together. Last example from lesson 21, page 93. This is letter D. First, we're going to identify our like terms. So we have 6 x's and a y right here. We have 6 x's and a y right here. And we have 6 x's. Oh, no, this is not the same. This is 6 y's and 1 x. So this is not the same. Okay, so it's only those two that are the same. This is xy, that's xy to the 6th. Those two cannot be the same. Okay, different amounts of exponents. Our variables are the same, exponents are different. You cannot add them together unless they're both the same. So we have one of these here and one of these here, so that's 2 total. I'm going to start with the biggest exponent value there with the 6. And it doesn't matter which order we put these in. I am going to change this to y to the 6th x so that that gets turned around with my biggest exponent first. So that is the answer.